As we all know, universe is a vast place. No one knows where it starts and where it ends. And also, no one ever from the planet Earth had gone through this place even beyond the solar system. But as new generation of high-definition apparatuses like telescopes invented, scientists and astronomers were able to see objects beyond the naked eye. So today, we will be reporting to you the two of the most common systems that compose the universe, the galaxies and the quasars.
Galaxy is a massive gravitationally bound system consisting of stars, stellar remnants, an interstellar medium of gases, dust, and dark matter. Unimportant but fully understood. The word galaxy is derived from the Greek word galaxias, literally milky, a reference to the Milky Way. Examples of galaxy range from dwarfs with as few as 10 million stars to giants with a 100 trillion stars, each orbiting their galaxy's own center of galaxies contain varying numbers of planets, star systems, star cluster, and types of interstellar clouds. In between, this object is sparse interstellar medium of gas, dust, and cosmic rays. Supermassive black holes resides at the center of the most galaxies. They are thought to be primary driver of active galactic nuclei found at the core of some galaxies. The Milky Way galaxy is known to harbor at least one such object. Irregular galaxies are typically originate from disruption by the gravitational pull of neighboring galaxy, which ultimately result in merger, sometimes induced from star formation leading to starburst galaxies.
Galaxies have been historically categorized according to their apparent shape, usually referred to as their visual morphology. There are different forms of shape. First is the elliptical galaxy. An elliptical galaxy is a type of galaxy having a approximately ellipsoidal shape and a smooth, nearly featureless, brightless profile. This is the example of elliptical galaxy. The second is the spiral galaxy. An spiral galaxy is a certain kind of galaxy that consists of a flat, rotating disk and a central concentration of stars, known as bulge. This is the example of spiral galaxy. There are two types of spiral galaxy. The first one is the barred spiral. A barred spiral galaxy is a spiral galaxy with a central bar-shaped structure composed of 8 stars. This is the example of a barred galaxy. The second is the unbarred spiral galaxy. An unbarred spiral galaxy is a type of spiral galaxy without a center bar. This is the example of unbarred spiral galaxy. And the last is the irregular galaxy. An irregular galaxy is a galaxy that does not have a distinct regular shape, unlike a spiral galaxy and the elliptical galaxy. This is the example of irregular galaxy.
Current cosmologically models of the early universe are based on the Big Bang theory about 300,000 years. After this event, atoms of hydrogen and helium began to form in an event called recombination. Nearly all the hydrogen was neutral and readily absorbed light, and no stars had yet formed. As a result, this period has been called the Dark Age. It was from density fluctuation in this primordial matter that larger structures began to appear. As a result, masses of baryonic matter started to condense within called dark matter halos. Within a billion years of galaxies formation, key structures begin to appear. Globular clusters, the central supermassive black hole, and the galactic bulge of metal population. Second stars from The creation of the supermassive black hole appears to play a key role in actively regulating the growth of addition matter added. During this early epoch, galaxies undergo a major burst of stars formation. During the following 2 billion years, the accumulated matter settles into a galactic disk. A galaxy will continue to absorb infalling materials from high-velocity clouds. Dwarf galaxy, throughout its life in this matter, is mostly hydrogen.
The Milky Way galaxy is home to our solar system. We see the plane of the galaxy as a band of light stretching across the night sky. It's a varied spiral containing about 200 billion stars. The diameter of Milky Way is 100,000 light years across, but only about 1,000 light years distinct. The major arms of the Milky Way galaxy are the Perseus, Sagittarius, Centaurus, and Cygnus arms for the constellations that are seen in those directions. The Milky Way is a halo of dark matter that makes up of over 90% of its mass. The age of the Milky Way, estimated of the age of the universe center, around 14 or so billion years old. Estimates for the age of Milky Way galaxy range from 800 million to 13.5 billion years old.
The Andromeda Galaxy. The Andromeda Galaxy is a spiral galaxy approximately 2.5 million light years from Earth. In the Andromeda constellation, also known as Messier 31 or M31, it is often referred to as the Great Andromeda Nebula in older texts. The Andromeda Galaxy is the nearest spiral galaxy to our Milky Way galaxy, but not the nearest galaxy overall. It gets its name from the area of the sky in which it appears, the constellation of the Andromeda, which was named after the mythological princess Andromeda. The Andromeda Galaxy is the largest galaxy of the local group, which also contains the Milky Way, the Triangulum Galaxy, and about 30 other smaller galaxies. The Andromeda Galaxy is probably the most massive galaxy in the local group as well, despite earlier findings that suggested that the Milky Way contains more dark matter and could be the most massive in the groupings. The 2006 observation by the Spitzer Space Telescope revealed that M31 contains 1 trillion stars, at least twice the number of stars in the Milky Way galaxy, which is estimated to be 200 to 400 billion. The Andromeda Galaxy is estimated to be 7.1 by 10 raised to 11 solar masses. In comparison, a 2009 study estimated that the Milky Way and M31 are about equal in mass, while a 2006 study put the mass of the Milky Way at negative 80% of the mass of the Andromeda Galaxy. The two galaxies are expected to collide in 3.75 billion years, eventually merging to form a giant elliptical galaxy. At 3.4, the apparent magnitude of Andromeda Galaxy is one of the brightest of any Messier objects, making it visible to the naked eye on moonless nights, even when viewed from areas with moderate light pollution. Although it appears more than 6 times as wide as the full moon when photographed through a larger telescope. Only the brighter central region is visible to the naked eye or when viewed using binocular or a small telescope.
The Sombrero Galaxy was discovered on May 11, 1781 by Piers Messier, who discovered the object in a May 1783 letter to J. Bernoulli that was later published in the Berlin Astronomisches John Birch. Charles Messier made a handwriting note about this and 5 other objects, now collectively recognized as M104 to M109. to his personal list of objects now known as the Messier Catalog, but it was not officially included until 1921. William Herschel independently discovered the object in 1784 and additionally note the presence of dark strontium in the galaxy's disk, what is now called a dust lane. It it's unclear exactly who discovered the galaxy, whether it is Pierre Michel or Charles Messier, because also William Herschel found the object independently in 1784, even though it had already been discovered by others. The majestic Sombrero Galaxy has a circled by thick dust lanes and graced with a brilliant glowing core. Is located on the near side of the Virgo clusters of galaxies, named for its hat-like shape. The Sombrero is a spiral galaxy with an exceptionally large central bunch of stars. Dust disk. The most striking feature of the sombrero is the dark and dusty disk, encircling the central of the galaxy. The dense clouds in this pizza-shaped disk are prominent. Starry bulge. The stars in the sombrero's huge oval-shaped bulge orbit around its starry bulge. The stars in the sombrero's huge oval-shaped bulge orbit around its core in all manners of directions. The diffuse glow of billions of stars make it difficult to find the edges of the bulge in this image. Infrared view. From the Spitzer Space Telescope's stars appear blue. White dust clouds appear red. Infrared light reveals the complete dust ring and the inner disk of stars, not easily seen in visible light image. Foreground stars. These stars actually within our own galaxy. Its distinctive spikes are caused by the diffractions of light around the stars, holding one of the Hubble's mirrors in place. You can identify the brighter stars in the sombrero image by looking for these spikes. For its backgrounds, this pane of spiral galaxy is probably about the same size as the sombrero. They appear to be interacting the gravity of each pulling stars and gas out of the other in long streamers. The image of sombrero is full of background galaxies much farther than away from us than the sombrero galaxy.
Ingay ni Maylin eh. Maffei 1 Galaxy. Maffei 1 Galaxy is a giant elliptical galaxy in the constellation of Cassiopeia. It was named after Paolo Maffei, who discovered it and the neighboring Maffei 2 in 1969 via their infrared emissions. Maffei 1 Galaxy is a slightly flattened core type of elliptical galaxy. It has boxy shape and is mainly made of old metal-rich stars. It has a tiny blue nucleus in which stars continue to form. Like our large ellipticals, it contains a significant population of globular clusters. Maffei 1 is situated at an estimated distance of 3 to 4 MPC or approximately 11,500,000 light-years away from the Milky Way, which makes the Maffei 1 galaxy closest giant elliptical galaxy to the Milky Way. Maffei 1 lies in the zones of avoidance and is heavily obscured by the Milky Way stars and dust. If it were not obscured, it would be one of the largest, about 3/4 size of the full moon, brightest and best known galaxies in the sky. Quasar, a massive and extremely remote celestial object emitting exceptional large amounts of energy and typically have a star-like image in a telescope. It has been suggested that quasars contain massive black holes and may represent a stage in evolution of some galaxies. In a universe containing hundreds of billions of galaxies, most of which has active nuclei billions of years ago but only seen today, It is statistically certain that thousands of energy jets should be pointed toward us, some more directly than others. In many causes, it is like that the brighter the quasar, the more directly its jets is aimed to us. Quasar shows the locations where massive black holes are growing rapidly via accretion. These black holes grow in step with the mass of stars in their host galaxy in a way not understood at present. One idea is that jets, radiation, and winds created by the quasars shut down the formation of new stars in the host galaxy, a process called feedback. The jets that produce strong radio emissions in some quasars at the centers of clusters of galaxies are known to have enough power to prevent hot gases in those clusters from cooling and falling onto central galaxies. Quasars are believed to be powered by accretion of material into supermassive black holes in the nuclei of distant galaxies, making these luminous versions of the general class of objects known as the active galaxies. Since light cannot escape the black holes, the escaping energy is actually generated outside the event horizon by the gravitational stresses and immense frictions on the incoming material. The matter accreting on the black hole is unlikely to fall directly in, but will have some angular momentum around the black hole that will cause the matter to collect into accretion disk. Quasars may also be ignited or reignited from normal galaxies when they merge and the black hole is infused with a fresh source of matter. In fact, it has been suggested that a quasar could form as the Andromeda Galaxy collides with our own Milky Way galaxy in approximately 3 to 4 billion years. It is said that after quasars finishes accreting the surrounding gas, dust and the stars, it become ordinary galaxies.
3C48. 3C48 was the first of many faint star-like quasi-stellar objects which later were named quasar. 3C48 was the first source in the third Cambridge catalog of radio sources for which an optical identification was found by Alan Sandage and Thomas Matthews in 1960 through interferometry. Jesse Greenstein and Thomas Matthews found that it had redshift of 0.367, making it one of the highest redshift sources than known. It was not until 1982 that the surrounding faint galactic nebulosity was confirmed to have the same redshift as 3C48, commenting its identification as an object in a distant galaxy. This was also the first solid identification of quasar with a surrounding galaxy at the same redshift.
ULASJ 1120 plus R641 is a quasar, the discovery of which was reported on June 29, 2011. As of June 2011, it is the most distant known quasar at a moving distance of 28.85 billion light years, and it was the first quasar discovered beyond a redshift of 7 Varius. News reports, including those provided by the Associated Press, have stated that it is the brightest object seen so far in the universe. Such statements are erroneous, however, that quasars are known to be at least 100 times more luminous.
3C273 is a quasar located in the constellation Virgo. It is the optically brightest quasar in our sky, magnitude 12.9, and one of the closest with the redshift Z. Ulit nga! 3C273 is a quasar located in the constellation Virgo. It is the optically brightest quasar in our sky, magnitude 12.9, and one of the closest with the redshift Z. Ulit nga! 273. 3C273 is a quasar located in the constellation Virgo. It is the optically brightest quasar in our sky, magnitude 12.9, and one of the closest with a redshift Z of 0.158. The name signifies that it was the 273rd object of the Third Cambridge Catalogue of Radio Sources, or 3C, published in 1959. It is the first quasar ever to be identified. 3C273 lies at the center of a giant elliptical galaxy with an apparent size of 30 arcseconds. 3C273 is visible in May in both the northern and southern hemispheres. It is bright enough to be observed with the larger amateur telescopes.
Normal galaxies support millions of stars that support billions of planets. Quasars are more similar to black holes. Although this issue has not been totally resolved, many astronomers now believe that the so-called quasars are the second step in the formation and evolution of new galaxies. So far, all new galaxies have been observed at distances that place them in time only about 1 billion years after the Big Bang event. It generally accepted that the first step in new galaxy formation of massive black holes located in dense regions of the universal gas that filled the young universe. An immense quantities of this gassy material was accelerated into the black hole at near light speed. High energy radiation was generated to flash outward. Some 12 billion years later, we observe this radiation source as quasars.